Hello again everyone. Welcome to Module 4 Part 2. This is the last part of our course. In Module 4 Part 2, we'll continue exploring the applications of inferential statistics. Today's focus will be on a powerful predictive tool, simple linear regression. By the end of this lesson, you should be able to use inferential statistics, specifically regression analysis, to analyze and interpret relationships between variables. Regression analysis is mainly used for two purposes. First, to describe how variables are related, to predict the value of one variable based on another. We use an independent variable, x, to predict a dependent variable, y. There are two types of regression. Simple linear regression, which uses one predictor and one response. Multiple regression, which involves more than one predictor. In this module, we are focusing only on simple linear regression. The slope of a regression line tells us the type of relationship. A positive slope means that as x increases, y also increases. A negative slope means as x increases, y decreases. If the slope is 0, there is no relationship between the variables. So, just by looking at the slope, we can understand how two variables move together. To make predictions, we use the regression line equation. So, here the model y hat equal a plus bx, where a is the y-intercept, b is the slope. These values are calculated using the least squares method, which minimizes the distance between the observed data points and the line. To see how well x explains y, we look at the coefficient of determination, or r squared. This tells us the proportion of variation in the dependent variable explained by the independent variable. For example, an r squared of 0.8 means 80% of the variation in y is explained by x. To determine the existence of a significant linear relationship between x and y, a hypothesis test is performed to test whether b, the population slope, is equal to 0. Let's apply this to an example. Suppose we're studying how the number of absence affects final grades. The value of a and b are estimated using the least squares method, and we get the regression line y equal 102.49 minus 3.62x. If the number of absence is 3, we predict the final grade to be equal to 91.63. The value of the coefficient of determination, or r squared, is 0.891. This result indicates that 89.1% of the variation in final grades is explained by absence. This is a very strong relationship. The remaining 10.9% is due to other factors not captured in the model. Next, we test whether the population slope b by using hypothesis testing. We found that b is not equal to 0, and we can conclude that a significant relationship exists between final grade and the number of absence. This concludes Part 2 of Module 4 and marks the end of our module. I hope you enjoyed the course, informative and enjoyable. Thank you.